TTP, time division multiplexing, used in hierarchical structure. Time division multiplexing is used in telecommunication system. How to use this time division multiplexing? It is a hierarchical structure used in telephone network. Network is interconnection of devices. Two or more devices are connected to sharing the information is called as the network. As with FDM, TDM hierarchical structure has been standardized in the US. This hierarchy is based on 64 kbps signals generated by PCM. When we are using the pulse code modulation, that will be converted into a bandwidth is 64 kbps. That can be occur from number of samples into number of bits. That's why it is bandwidth is equal to bitrate is equal to n into f of s. N is the 8 bit and f of s is 80,000 samples per second. Then at a lowest level 24 voice channels are multiplexed, and at the lowest level 24 voice channels are multiplexed together at the byte levels. Note this corresponds to 1 samples of analog voice signals. Then TDM, time division multiplexing. TDM, time division multiplexing is the method of transmitting and receiving the independent signals over a common signal path by means of synchronization switches at each end of the transmission lines, so that each signal appears on the line only a fraction of time in an alternating pattern. Transmission of lines appears on the line only a fraction of time in an alternating pattern. Then we have the next slides. It is going to be next slide of the time division multiplexing. The method of transmitting and receiving. These two signals are independent signals. The transmitting end and the receiving independent signals over a common signal path by means of synchronized switches. They have to use the synchronized switches or rotary switches at each end of the transmission line, so that each signal appears on the line only. Each signal appears on the line only a fraction of time in an alternating pattern. One by one to select the sampled voltage. One by one alternating time fraction in an alternating pattern. It is a communication process that transmit two or more digital signals. It is a communication process that transmit two or more digital signals Digital signal in the form of square wave pulses 1 and zeros, or analog signals over a common channel, or analog signals over a common channel. The digital signals, two or more digital signals are analog signals over a common channel. It is used when the bitrate of the transmission medium exceeds that of the signal to be transmitted. Bitrate can be calculated n into f of s. F of s is the sampling frequency of the signal. N is the number of bits where to transmitted that is the bandwidth of the any devices. Then the transmission medium exceeds that of the signals to be transmitted. This form of the signal multiplexing was developed. This form of a signal multiplexing was developed in telecommunications for Nowadays telecommunication means voice signals. For telegraph and non-voice signals can be transmitted through the communication. You can transmit, it can utilize. Nowadays the number of various companies are transmitting the informations like a voice signal and also non-voice signals. Voice signals are like speech signals, and non-voice signals are taken as the data to transmitted to a network to share the information by the different users. Different users and different states, different countries can sharing the information worldwide or globally can share the information. Telegraphy system in the late 19th century but its most common applications in digital telephony, but found its most common application in digital telephony in the second half of the 20th century. Then we have to go to the next slide of this TDM. TDM used in hierarchical structure as shown in the diagram. This is the basically North American countries are first established. Various countries are utilized different multiplexing, that is a time division multiplexing, and North American digital telephony hierarchical structure, this one. And to take the advantages of merits of the time division multiplexing and digital signal transmission, the common carriers employ a hierarchy of a multiplex. As seen that I have seen here that a multiplex is the basically as shown in the diagram here. First, the standards of first message signals are at a time to multiplex 24 voice signals. 24 voice signals are 24 users. Any users, 24 users at a time can share the information. That signal is the input signal, that is called a DS0. DS0 means a digital signal 0. It is the transmission of a 24 voice signal. 24 into 24 voice signal, 24. Here we have to sampling the each signal. Sample the signal is 8 bit. 8 into we have to take the samples of the 24. The basically sample the each sampling the 8 bits into sampling frequency is 8000. That is the standards of voice signals to transmitting the signal to sample by using the sampling theorem that we have to used in PCM techniques, pulse code modulation techniques. This pulse code modulation techniques is PCM are used. PCM is the pulse code modulation. PCM is used as a PCM modulation. The sampling frequency is 8000 samples per second into number of bits is taken as a 8 bits. We have taken the number of bits, that 8 into 8 is 64 kilobits per second, and that each signal, how many signals are digital signal here transmitted means 24 into 64. Then the output of this first mux, that is a time division multiplexer. Here many inputs and get the single output. The basic concept of that multiplexer working is many signals are added to get the single output. That output of this data is 64 into 24, that is 1.544 megabits per second. That the bandwidth is equal to 1.544 megabit per second. That is the output of the DSO 0 into 21 inputs, 24 into DSO. That is the output of this first mux. This mux input output is connected to the input of the second level. These are the first level of the output is connected to the second level of the mux. The output of the first mux is connected to this time division multiplexing. That is the 1.544 megabit per second. 24 DSO means 1.544 megabits per second. 24 into DS0, the output is connected to the second mux. That having the multiplex, the 4 inputs are multiplexed to the previous output of the first mux, then multiplied each output of the first mux multiplexed with the second level of TDM. Then multiplex the voice signals are 24 into 4, totally increased here by increasing the voice levels are increased, and that is the output of DS2. The DS2 get the output of the DS2 is the DS 4 times of DS1. 4 times of DS1 is equal to output of DS2. That is the bandwidth is 4 times multiplexed with this 1.54 due to some guard band. Due to the some guard band is requirement to non-overlapping of the signal to avoid the interference. That's why you have to using this added to the some more bits, that we had bandwidth is increases. That bandwidth is equal to 6.312 megabit per second. That bandwidth is increases to 6.312 megabit per second. That is the output of the second mux DS2. This data will be that DS2 is equal to 4 times of DS1. 4 times of DS1 we have to get the output of this DS2. Output of the DS2. Then we have to use DS2. Output of the DS2. Output of the DS2. output of the DS2, output of the DS2, output of DS2, output of DS2, output of DS2, output of DS2 is DS2 is equal to 4 times of DS1 into 6.312 megabits per second. Then this output is multiplexed with the third level. We have to go to the third level of the time division multiplexing. Here we have to multiplex the how many signals are multiplexed here. Third level is 1 2 3 4 5 6 7. 7 inputs are multiplexed previous output of the second level of the mux. Then we have to multiplex each output multiplex with the input. Then we have to get the DS3. DS3 is getting the 7 times of DS2. The inputs are 7 signals are multiplexed. Each is 7. Each individual signal is DS2 into 7. Then we have to get this output of the DS3. Then we have to increase the bandwidth is 44.376 megabits per second. We have to get 44.376 megabits per second. That we have to get in the output. Then the output is multiplex. This is the third level of the mux. This will be a third level of the mux. Then we have to third level of the mux. Output is multiplexed with this. Fourth level. Fourth level is we have to take these 6 inputs of multiplex to the previous mux. DS3 into 6 times we have to get the DS4. Then we have to bandwidth is equal to previous bandwidth is equal to 44.376 megabit per second is multiplied with the 6 multiplexing the signals. Then the bandwidth increases. That bandwidth is increases, that will be goes to the bandwidth is goes to this 274.176 megabits per second. The bandwidth is goes to the 274.176 megabit per second. In this way we have to multiplex, increasing the number of channels and also increasing the bandwidth to utilize the more number of users. That's why it is a hierarchical structure of time division multiplexing. This is the hierarchical structure of time division multiplexing techniques. Basically it is transmission of the signals only it is utilized for this digital data signal can be processed and digital data can be transmitted. This is the far way to construct this digital signal. This is a hierarchical structure. This is anyone can hierarchical to increases first level, second level and third level and fourth level. Goes on increases. It will be goes on increases to increasing the bandwidth and also increasing the voice channel. In this way we have to utilize the signal. Next slides is going to be taken the explanation about this American digital hierarchical structure. First they have to identify that the T1 carrier system. T1 carrier system was designed to combine PCM, pulse code modulation and time division modulation techniques for the transmission of 24 into 24 voice signals that can be used as 64 kbps channels. 64 bandwidth is equal to 64 kilobit per second channels with each channel cable with each channel capable of carrying digital encoded voice band voice encoded digital encoded voice band telephone signals or data with each channel capable of carrying a digital encoding voice band telephony signals or data. The transmission of bitrate line speed of a T1 carrier is first T1 carrier is the 1.544 megabits per second. That is the first bandwidth to identify the channel. First level, that is a T1 carrier to identify anyone. That utilization of bandwidth is maximum bandwidth is 1.544 megabits per second. Then next level it will be going to be all 24 DSO channels. All 24 DSO 0 channels combined all 24 digital signal 0 channels combined has a data rate of 1.544 megabits per second. The data rate of the bandwidth is 1.544 megabits per second. This digital signal levels is called digital signal 1. The digital signal DS means a digital signal levels first level, that is called as a DS1. Then there is a T1 lines are referred to DS1 line, where the T1 line you get the output of the DS1 line. Then we have to go to the next slide of this hierarchical structure of time division multiplexing. Then we have to go to the next slide. To take this some lines which line we have to taken and what is the bandwidth, how many channels. This is basically standards of this services provided by the various services are provided by the time division multiplexing. And the time division multiplexing are 4 levels we have to use. 4 levels are used, that is the DS1 level and services DS2 level and DS3 level and DS4. There is a hierarchical structure, the hierarchical structure that we have to increasing the bandwidth of this multiplexer first level, and also bandwidth increases at the second level, and also voice channels are so improved. And DS3 is the third channel, the time T3 third channel DS3, and also increases the voice channel. It also increases the voice channel. Voice channels also improve, and DS3 and DS4 also digital signal fourth level, the data signals also improved. In this way we have to increasing the voice channel and services, various services of digital signal 1, digital signal 2, DS signal 1 taken as the first line, T1 line. First we have to services provided by the multiplex, and level line, which line we have to utilize, which line we have to capable to connecting the various number of users to identify the which bandwidth are there for different lines. Bitrate is equal to megabit per second, Mbps. bits per second data rate. The data rate is equal to megabit per second. Then we have to go to the voice channel. That voice channels are taken into voice channels. Voice channel is taken into how many voice channels are there? 24. 24 voice channels are required. 24 voice channels are required. Then we have to go to the DS2, digital signal 2. Digital signal 2. Digital signal 2 is the line T2, taken as the line T2, and bitrate is in the form of megabits per second bitrate. That bitrate is increased and improved. That bitrate is equal to 6.312. Bitrate is equal to 6.312. The voice channels are improved. The voice channels are increased. That voice channel is equal to increased by the 96. Bandwidth also increases and voice channels also increases at the line T2 line and a digital signal S2. Then we have to go to the DS3. DS3, the digital signal third level, the taken as the line T3. The megabits per second bitrate is equal to 44.736 bitrate, and voice channel is 672. Increased by the voice channel also increased here, and 672 voice channels can be allocated at the DS3, digital signal 3. Then digital signal 4, DS4. DS4 is equal to digital signal 4, the taken as the line is equal to T4. T4 is the T4 is the line as taken T4. Digital signal 4, that is the bitrate or increases. Data rate bitrate are increases to 274.176 megabits per second mbps. Bitrates are increases. The voice channels are improved. That voice channels are getting 4032 bits. In this way we have to utilize the line by different T lines, T1, T2, T3, T4. Data signals are services provided by the users, DS1, DS2, DS3, DS4, bitrate and voice channels. Then we have to go to the next slide. Next slide of this time division multiplexing. T2 carrier system. T2 carrier system is time division multiplexing, 96 voice channel and 64 kilobits per second data. Voice signals are data signals. Data channels, voice signal can be transmitted, data signal can be transmitted. Data channels into a single 6.312 megabits per second data signals for transmission over twisted pair copper wire up to 500 miles over a special metallic cable. Copper wire up to 500 miles over a special metallic cable. And how much distance or far away distance used for T2 is equal to 500 miles. 500 miles over a special metallic cable. Then we have to using the T3 carrier system. T3 carrier system is T3 carriers time division multiplexes 672, that is 64 kilobits per second. The voice signals are transmitted and data channels for transmission over a over a single coaxial cable. Transmission over a single coaxial cable. The transmission rate is improved. The transmission rate is improved 44.736 megabits per second. In this way, we have two transmissions are transmitting, and then we have to go to the next slides. Next slide is T4 carrier system. T4 carrier system. T4 carrier system is time division multiplexing. It is used for voice signals or voice channel 4032 and taken as a 64 kilobits per second kbps, that is the voice signals or data channels are for transmitting over a single line T4 coaxial cable up to 500 miles of distance can be carried at a high speed of the signal without any losses, without any disturbances. Quality of the data and quality of the signal can be transmitted through internet. The transmission rate is very high. That is 274.16 kilobits per second. That we have the transmission at the rate of transmission. Transmission is very high, that is equal to 274.16 kilobits per second. Then we have to take this T5 carrier system. T5 is the T5 carrier system. T5 carrier time division multiplex, that is equal to 8064, that is equal to 64 kilobits per second voice signals are data channels, and transmitted them at 560.16 megabits per second over a single coaxial cable. We have to transmit. The coaxial cable can be used. The quality of the voice signals, quality of the data can be transmitted. The improve the quality without any good quality of the images, good quality of voice signals, and good quality of your designing of the equipment. All those this is the best way to utilize this time division multiplexing, and voice signals and data channels are transmitted them over a single coaxial cable. The next slides will be going to be next slide. Of this next slide, it is taken as the time division multiplexing. I have to take this time division multiplexing. The frame rate is, for example, we have to take this frame rate. That frame rate, we have to take this frame rate. We have to take this frame rate. Frame rate. We have to take the frame rate of the time division multiplexing. Frame rate of the time division multiplexing. Frame rate. This is the various hierarchical structure of this hierarchical structure of the time division multiplexers. The hierarchical structure of your time division multiplexing. The hierarchical structure of the time division multiplexing. And the two tabular form, and also utilize also you can take this number of frame bits and number of frame bits and utilized by the number of frames. Time division multiplexing. Also, time division multiplexings are used for the data bitrate. Here we have to take this bitrate. The bitrate is frame rate. The frame rate. The slides taken as the slide. We have to take this frame rate. We have to take the frame rate is 50,000 frames per second. 50,000 frames per second, and each frame carries 8 bits. Then simply to calculate a bit rate is equal to 50,000 frames per second. 50,000 frames you can be sent, and each frame is contain 8 bits. That is equal to 50,000 into 8. That is equal to 400 kilobits per second. That's why we have to find out the bandwidth of this bit rate. To find out this bit rate, you can find out the bit rate. Similarly, what is the bit duration? What is the time? How much time to transmitting the quality of the signal? How much time can be find out this time? That is the bit rate is or bit duration. Bit time or bit duration. Bit duration is equal to 1 by 400 kilobits per second. 400 kilobits per second. Easily to calculate this bit rate. The time duration is 1 by 400 kbps, that we had collected by the 2.5 microseconds. The time is taken 2.5 microseconds. The telephone companies are implemented time division multiplexing through a hierarchical structure of a digital signals called digital signal services. And then we have to take the 50,000 frames to transmit per second. How much time to transmit to received by the signal? That signal is taken as the time is 2.5 microseconds. 2.5 microseconds is equal to 2.5 into 10 to the power of minus 6 microseconds of time, and less time to take to 50,000 of frames. That's why you can find out the bit rate of the signal. Bit duration is equal to 2.5 microseconds. Telephone companies, this is the digital signal services. The digital signal services. This is a way we have to find out the any bandwidth of the signal by bit rate. You can find out the frames. If it is 1000 frames, or example 1000 frames per second, then each frame carries 8 bit. That will be taken as 8 lakhs. 8 lakhs is 800. The bandwidth bit rate is taken as 800 kilobits per second. Then what is the time duration? You can calculate 1 by frequency, and bit rate 1 by frame duration, 1 by 80,000. That 80,000 and that will be taken as a 1 by 8, 1 by 4 and 1 by 8. The less time to transmission of this bit duration is simply we have to calculate by 1 by frame rate. This is the many telephone companies are implemented by time division multiplexing through a hierarchy of the digital signals called digital signal services. many companies, either Airtel companies and BSNL and MTNL and also Idea, and all networks are implemented by these techniques. That is, techniques is time division multiplexing techniques. Then we have to go to the next slide. Next slide is, this is the way we have to frame rate. Any frame rate we have to find out by the time division multiplexing, right? Then we have to go to the next level where we have to use the time, where we have to use it for this time division multiplexing. The time division multiplexing are used, time division multiplexing are used for this. TDM is used for long distance communication link, long distance communication link, long distance communication link, long distance communication signal, long distance communication signal, long distance communication signals. The TDM is time division multiplexing is used for long distance communication link, 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 long distance communication, long distance communication link. That we have to use linked with this time division, and very heavy data traffic loads from end users. We can manage and bear heavy data traffic loads from end users. And synchronous time division multiplexing is used for high speed transmission, is used for high speed transmission of data, high speed of the transmission of data, high speed of the transmission of high speed to transmission of this data. Most of the telephone companies are used for internet, high speed of the data, and these technologies are implemented. This is the way we have to use it for long distance communication links worldwide or globally, to accessing the data from the internet, and also bear the heavy data traffic loads from end users. Synchronous time division multiplexing is used for high speed of transmission, high speed of transmission of the signal. This is the way we have to multiplexing the hierarchical structure of the time division multiplexing. Technology is most suitable for all the best companies, and this is the most useful technology to transmission of the data. That's why we have to, shortest distance can be linked with the data, and most of them worldwide we have a long distance. That is the better to everyone to use this data. This is the hierarchical structure of time division multiplexing.